Morning, everybody. Video 5, naming ionic compounds. So still in ionics. It's going to be a while before we're out of ionics. Today we got to learn how to name them. If we name them, we got to go backwards and forwards. So this probably is going to be 2 videos. Use the charge cancellation rules to find out the chemical formulas. So that's the backwards and forwards all in one video. Thank goodness. So naming rules for our ionics. Here we go. So it's always a metal and a non-metal. So the name is going to be metal, followed by the non-metal ending in "ide." So classic ones: sodium chloride, metal, sodium; chlorine, non-metal, ending in "ide," sodium chloride. I would sprinkle a little of that on my French fries. I like it. If the metal is a transition metal, though, that specifically has multiple charges. So I'm going to take a peek. I see iron's a big one. Nickel, copper, cobalt, manganese, Mn has 4 charges to choose from. Okay, so if I have multiple charges, I need a Roman numeral to let me know what the charge is, because that's a big deal. And then if there's a polyatomic ion present, I just name it directly off the table E. So those are the basic ground rules. We're going to go through all of them with examples so you understand what's what. Okay, so first example, ionic compounds that do not have transition metals. This is as simple as it gets, okay? I got Na, I got Cl. So I already actually just did this for you, not knowing, but the Na is sodium. And then the Cl is chlorine. The chlorine becomes chloride. I lose the ene and add the ide. So it becomes sodium chloride. Okay? And Li is lithium. Lithium and bromine, Br is bromine. Bromine becomes bromide. Okay, lithium bromide is how we say this. We have to follow these rules specifically. It helps me know. Ide tells me that it's a bonded compound. Examples of naming ionic compounds that do have transition metals. So this is where things get a little bit crazy. You might want to watch this first. I'm going to take up the screen. If the metal is a transition metal with multiple charges, hold on, here's a that's annoying. If the metal is a transition metal with multiple charges, I need a Roman numeral to tell me the charge. Okay, so this is going to work so we can go backwards and build the molecules from the name. So that's why it's so important. So I have FeCl3. Okay, Fe is iron. Cl3 is chlorine, and then here's where the trick comes in. Ready? It's definitely iron chloride, but Fe can be a +2 or a +3 charge. So we use the number of chlorines, of course, to figure it out. So the first element in the compound is always positive. The second element is always negative. You want to put a star around that somewhere. You want to write that somewhere off. That is a given rule for the entire year. Okay. When I look up Cl on the periodic table, it only has the one negative charge. I know it must be negative because it's the second element, and it's -1. If there are 3 chlorines, that's a total of -3 charge. There's 3 -1s, and I think we can do that math pretty easy in our head. 3 times -1 is -3. So if I have a -3 on one side, what's the one positive number have to be? There's no number after iron, and I know that this hasn't been formally done yet. I think I talked about it earlier on in this unit. No number as a subscript after Fe means there's one of them. The fact that I wrote the letters means there's one. If there was a 2, it would be a different ball game, but there's not. There's 1 iron there. I have a total charge of -3 on chlorine, so the total positive charge has to be +3 to cancel it out. So we have a +3 charge to cancel out the -3. Therefore, I'm going to put a Roman numeral 3 after the iron. The Roman numeral 3 is going to tell me it's an iron with a +3 charge than the chloride. And this way I can go backwards and forwards and do that molecule properly from the name. All right, here conversely is iron chloride with a Cl2. So notice the difference. It's still iron. Chlorine is still going to become chloride. But now I get a Roman numeral 2 because chlorine has a negative charge of -1. 2 -1s is a -2. So now the positive charge on the iron must be positive 2. So that Roman numeral 2 is telling me the charge on the iron. I can figure out the charge on the chlorine pretty accurately, pretty quick. The iron I wouldn't know, so I need that. Okay. Ooh, there's an old relic left over from last year. If there is a polyatomic ion present, we're just going to name it directly off table E. So here's table E. Now I see why I left it, because I didn't see it over underneath this. So CaCO3, calcium is Ca. We got that from the periodic table. CO3, I find here, it's carbonate, so I just call it calcium carbonate. That's simple. And then I'll use those charges if I need to when I need to build these things. So KPO4, K is potassium. PO4, I look it up on my table E, it's phosphate, so this is potassium phosphate. That's simple. Okay. One more. Ooh, this one has 2. NH4 is a polyatomic ion. We do need to get very familiar with this table so it's easier to pick these out. The fact that they're capital letters is what lets me know, okay? Because 2 capital letters means more than one element. More than one element probably means polyatomic ion when they're together like this. Okay, so this is ammonium nitrate. And with that, we've learned now how to name the ionic. So practice, and make sure you check your work. Please make sure you check your work so you know that you're getting it right so that you can perform well on the test.